بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. مساء الخير للجميع. شكرا جزيلا على هذا الحضور الكبير في محاضرة قيمة إن شاء الله اليوم باسم مركز الشيخ إبراهيم بن محمد الخليفة للثقافة والبحوث، وباسمكم جميعا نرحب بالأستاذ الدكتور هشام العش من جامعة الشارقة. ضيفنا ضيف عزيز وكريم علينا اليوم. الدكتور هشام مختصر مفيد للسي في طويل جدا، ولكن احنا راح اختصر. الدكتور هشام حاصل على الدكتوراه من جامعة السوربون. جامعة السوربون جامعة جدا مشهورة، وأساسا تابع إلى كلية ماري كوري. وماري كوري الإنسانة الوحيدة اللي حصلت على جائزتين نوبل بالفيزياء ونوبل بالكيمياء. فلنا الفخر أنه هو خريج جامعة السوربون. الدكتور هشام اشتغل في مراكز علمية مرموقة في العالم، من ضمن المراكز مركز ماكس بلانك في ألمانيا، وبلانك هو مؤسس الكوانتم ميكانيكس، فهو عمل في هذا المركز العريق في ألمانيا، وعمل في جامعات أمريكية وكندية من ضمنهم جامعة تكساس وجامعة برينستون في الولايات المتحدة الأمريكية. الدكتور البروفيسور هشام نشر أكثر من 270 مقالة علمية قيمة. الدكتور هشام له 12 براءة اختراع، أعتقد 12 براءة اختراع في تقنيات الكم أو تقنيات الكمبيوتر، الكوانتم كمبيوتر. أوكي، فإحنا باسمكم نرحب بالدكتور هشام. المحاضرة علمية بحتة، وإن شاء الله قيمة بحتة في موضوع جدا مهم. هذا الموضوع أساس التقدم العلمي والتكنولوجي، وإحنا الآن عايشين في عصر التقدم العلمي والتكنولوجي. لولا معرفتنا بالكوانتم ميكانيكس لما وصلنا إلى هذا اليوم. بداية الكوانتم ميكانيكس، أنا أعطي نبذة صغيرة والدكتور راح يبدي بالمحاضرة باللغة الإنجليزية. في بداية القرن العشرين لاحظ العلماء ظواهر في المادة لا يمكن تفسير هذه الظواهر باستخدام الميكانيكا الكلاسيكية أو التقليدية. من ضمن الظواهر إشعاع الجسم الأسود، تأثير كومبتون، التأثير الكهروضوئي، ازدواجية الجسم والموجة. إذن عدم تفسير الظواهر أجبر العلماء في البحث عن وسيلة أخرى أو عن مفهوم آخر لتفسير هذه الظواهر أولاً، ومن ثم بناء نظرية أخرى. النظرية أو نسميه الفرضيات للأجزاء الصغيرة جداً من المادة، الذرة فما دون، وإحنا نعرف التكنولوجيا مبنية على الذرة فما دون. فإذا فرضيات الميكانيك الكمي تم بناء الفرضيات بجهود علماء ليس عالم واحد، بينما دائما نذكر قانون نيوتن عالم واحد فقط. إذا من ضمن العلماء نذكر اسماء بعضهم: ماكس بلانك اللي هو مؤسس الكوانتم ميكانيكس، العالم بور، العالم أينشتاين، العالم شرودنجر، العالم بورن، ومجموعة أخرى من العلماء في غضون 20 سنة إلى أن أسسوا الكوانتم ميكانيكس أو فكرة الكوانتم ميكانيكس. ومن ثم بعد التأسيس وبعد التأكد بدأ التطبيق الآن. الكوانتم ميكانيكس مبني على أساسيات. فأساسيات الكوانتم ميكانيكس: أولاً مبدأ أن الطاقة غير مستمرة مكممة، هذا المبدأ غير موجود في الميكانيكا الكلاسيكية. اثنين، مبدأ عدم الدقة. في الميكانيكا الكلاسيكية كل شيء دقيق، الجسم أمامي أقيس بدقة. الإلكترون لا نرى بالعين المجردة، إذا نبحث عن الإلكترون، فهنالك احتمال هنالك عدم دقة في قياس الموقع، فيكون على حساب كمية أخرى بالفيزياء. فإذا المبدأ الثاني. المبدأ الثالث ازدواجية الجسم والطاقة والموجة. في الميكانيكا الاعتيادية الجسم جسم والموجة موجة، إذا يجب أن نفسر الازدواجية وندرس الازدواجية. المبدأ الرابع مبدأ corresponding principle، أنه كل شيء في الميكانيكا الكمية لا يلغي الميكانيكا الكلاسيكية، الميكانيكا الكمية تكمل للميكانيكا الكلاسيكية. إذن الاثنين صح، ولكن كل ميكانيك في موقعه. فإحنا اليوم إن شاء الله راح نتمتع بتطبيقات الميكانيكا الكمية ونصل إلى التطبيق الحديث جدا اللي هو كوانتم كمبيوتر. شكرا جزيلا دكتور هشام على قبولك للدعوة وحضورك إلى مملكة البحرين، وإن شاء الله الكل ينتظرون المحاضرة. شكرا جزيلا.
شكرا. السلام عليكم ورحمة الله وبركاته. مساء الخير الجميع. في البداية أود أن أتقدم بالشكر والامتنان إلى مركز الشيخ إبراهيم بن محمد آل خليفة للثقافة والبحوث على الدعوة الكريمة لي لإلقاء هذه المحاضرة عن فيزياء الكم وتطبيقاتها، ولحسن الضيافة. كما أود أن أتقدم بالشكر لصديق العزيز الدكتور محمد يوسف من مركز ابحث ومن قسم الفيزياء بجامعة البحرين على منح هذه الفرصة السانحة. شكرا جزيلا للحضور الكرام، وأتمنى أن تكون المحاضرة شيقة ومفيدة وسهلة. أستسمحكم بتقديم المحاضرة باللغة الإنجليزية. تقدم الميكروفون. Okay. So I will speak today about the concept of quantum mechanics and its applications. So first of all, let's speak about the outline of the presentation. The first part will be dedicated to the concept basis of quantum mechanics, and the second part will be dedicated to applications, mainly to quantum computing. So let's begin with the first part, the conceptual basis of quantum mechanics. So if you see the technology based on quantum phenomena, they are around us. For example, transistors. What is the transistor? It's the basis of computers or digital communications, phones, etc. So more than that, laser pointer here, but has several applications in medicine, in optical communication. So there are millions of kilometers in fiber where they transport data, mainly internet, phones, from continent to other. So then, if in the medicine, magnetic resonance imaging, this is a powerful tool, one of the most powerful tools. So to discover the body, inside the body in 3D. And this is based on concept of quantum mechanics, in particular about the quantum spin property. So another things, I cannot go from one place to another without using the GPS now, right? You are using GPS, and this GPS is based on atomic clocks for geolocalization. So let's begin very simple, and begin with the concept of classical mechanics. Imagine I have a particle, a car, very simple car. I can consider the particle is car when I am far from, okay? And that's a simple way. Moving along the x-axis, and suppose this car is subject to a force F. I am pulling the car. And this, I know in classical mechanics, it's easy to determine the position on the speed or velocity in function of time just by using the second Newton's law, F equal ma. Okay, this is very simple, we know that. So now, let us try to apply the classical mechanics to the atoms, such hydrogen atom. Hydrogen atom is mainly, you have a proton around it by one electron turning around, okay? And you know, this is the classical description of the hydrogen atom as electron orbiting about a proton, as I told you. So this is one classical law. That's when you have electron turning, it's a charge. When charge is turning, it has acceleration. It's emitting electromagnetic wave. That means it's dissipated energy. So when you dissipate energy, what's happening? It's coming around, and then go to the proton, right? So exactly, it will be nice if it will be billions of years. But if we calculate it with the classical mechanics, with the classical electromagnetic, what we have? Fraction of a second. My God, something wrong. Repeating the calculation, repeating again. No, this is not working. because there's something is intriguing here. How the hydrogen atom have existed for billions of years. So this is strange, okay? There is something wrong. One of the possible problem is that the concept is not adapted. I am applying classical mechanics to describe atoms. So what I should do, the law of classical physics are not working in the atomic scale. So we need another theory. That is the birth of quantum mechanics. I am using this as a proof somehow to use the quantum mechanics. Historically, it's not exactly, but to simplify, we should somehow cheating on giving some nice things in order to. But physically speaking, this is another proof that the quantum mechanics is needed. So, in historical context, let's return to the historical context of the birth of the quantum mechanics. One of the first father maybe of the quantum mechanics is Max Planck. Max is German. And then he postulated the quantization postula. That means that is the concept of quantized energy. Let's forget the energy or the things. Let's take sample things. If you go to your bank, you see your bank statement. I am from UAE. I will see my statement, for example, 1,000 dirham, 3 fils, but I never seen a fraction of fils. The fils is the smallest things. The smallest, that is the unit, the smallest unit. That means the money is quantified by fils. That's what we call it, quantified. That is the minimum. Any money I have, any note I have is quantified by fils. And any transaction can be in banks, only the smallest unit is the fils, anyway. So if you go to ATM and want to have money, that's the same in Bahrain, in UAE is the same, the minimum amount that you have is 20 dirhams, or multiple of it. You cannot ask the bank to have, from ATM to have 95. It's not possible. 100, 120, or 2,000, and 200, etc. Okay? This is the smallest package, the unit, the quantum, if you want, the quantum. Okay? This idea was more developed with Einstein. We say, okay, Einstein, I will not speak exactly about the phenomena of photoelectric, but Einstein said, okay, light consists of discrete package of energy, call it photons. That means when you speak about the energy of the light, if you want to measure the light, it's a multiple of the number, the characteristic of the photons. So the photon is the smallest unit. And here, when you are specialist, so if you give one photon to the electron, you can eject one electron. But there is some specific things that is about the frequency and so on. And we're not going to the specialized things here, just because we don't have time. This is very nice. Einstein get the Nobel Prize because of this, not because of the special or general relativity. You know that. And more than that, go to the Louis de Broglie. He's from France, born in 1892. And he has like very strange concept. Say the duality between wave and particle. So particle, or particles in general, we can speak about, for example, electron. Electron can illustrate or exhibit both particle and wave characteristic. So that's the things is coming more or almost established the quantum mechanics with Schrödinger. Schrödinger developed his, Erwin Schrödinger developed his Schrödinger equation. Okay, I will speak about Schrödinger equation without writing it. So let me explain it in simple way. So let's take the very simple. Suppose that I am poor enough that I have only money to buy the water from machine. My wealth, which was in instant T0, in this instant, is I have a money. I put it in machine. After the instant, after what I have, what is my wealth is the bottle of water. So this, I transform my wealth from one position to another, or from one time in another. Schrödinger equation, exactly the same thing though. Let's take the propriety of the particle and predict this propriety after certain time. It's like a machine. They think like a machine. Forget all what we do in mathematics, just a machinery of what we call it operator, whatever. So this is exactly the same. So avoiding to write Schrödinger equation, a little bit complicated, but in any case, it's not adapted maybe for here. So let's continue more. The concept of quantum mechanics is based on on interpretation, because this is the most important in physics, not the equation. The way to put the equation speaking. What is the equation told me? What is the interpretation of it? By the way, this is the nutshell, okay? And then between 1920 and 1930, Copenhagen interpretation of quantum mechanics was established. On this is set of principles formulated by Niels Bohr, Heisenberg, Max Born, Max Planck, and so. One of the most intriguing, I think that is one of the most intriguing, is the concept that the quantum mechanics is probabilistic, non-deterministic, unlike classical mechanics. That means I can exist here with a certain probability and here with certain probability if I'm quantum particle, okay? So in classic, I'm existing here. But in quantum, I can have a probability to exist here and here. Any scientist, if only probabilistic, not because we don't know the information, because the physics of quantum is like that. It's non-deterministic. It changes the concept of philosophy. It's totally different. So we cannot predict the future exactly. Before, with the concept of Newton, we can detect, if you know all, we can predict the future. No. In quantum mechanics, even you know all the things about the system, you are not able to predict. You have only possibility to predict with the probability, not the deterministic one. This is the concept of quantum mechanics since life. So here, more than that, sorry. So Heisenberg give even and insist about this concept differently. He said, okay, you see, this is the position, that is the velocity. If I know exactly, when it's come now, the position, I cannot know the velocity. If I know exactly the velocity, I don't know exactly the position. So that I should have a compromise between the unknown part of the velocity, the known part, or uncertainty about the velocity, uncertainty about the position. And there is several other ways derived from that. Okay, this is in 1927. So excellent way of thinking that's never seen before in the science. Way totally different way of thinking, counterintuitive. It's like alien thinking. And then let's return here and insist it. Remember, in classical mechanics, once we know the force, we can derive all the position on the velocity in any time. That is deterministic. So, as I told you, quantum mechanics is different approach. And based on what? The properties of the quantum mechanics is built on wave function, what we call it wave function. Okay? On wave function to determine it is by solving Schrödinger equation. Remember that we have before, if you know the wave function at position on the space at a certain time, you could predict the property at a certain position on time after. Okay? So here is really, I want to show the importance of Schrödinger equation. And one scientist, Ian Stewart, tried to see what is the most powerful equation or the equations that they have changed the world. And Schrödinger equation is in the list. Okay, I was avoiding to write the equation. I have taken the equation out. Sorry for that, but in order to not to disturb you. But the real list, there is the equation written. Okay. And then here, as I told you, I think this is here again. Again, this is the interpretation of quantum mechanics. And I insist about it again and again and again. The wave function characterizes the quantum mechanical particle, its temporal properties. And then here, a particle. I spoke about wave function, wave. But I have particle. A particle is in one place. A wave is dispatched in the space. So how can a wave describe a particle? So let me try to explain this in easiest way. Maybe we can have a way to understand this. So wave, in order to understand wave, let's take examples. Water wave or electromagnetic wave. What is the characteristic of the wave? What is the most important characteristic of the wave? We call this wavelength, lambda. The wavelength is the distance between two maxima or two minima, okay? From that, we go here, and we want to understand what is the wave, what is the propriety of the wave. The propriety of the wave is the most important properties is the interference. Let's suppose that you have two sources of waves. You see here, two sources here. Two waves coming, and then what happening is there is interference. See here, for example, wait a moment, where is the light here? See here, you have maximum of the first with superposed with the second. We have a maximum, big maximum. But here we have minima with minima, you have minima. So minima and maxima. But let's see, that's what we call it constructive interference. But here, if you see maxima with minima, is inhibiting both of them. There is like no wave here. So the pattern is here. You have a maxima, minima, and you have nothing. Nothing. This is like, there is no disruption there. This is the pattern. Remark these patterns here for interference. Any wave, electromagnetic wave, water, whatever, it's the same interference pattern. Now, let's go furthermore. And see here, the experiment of double slit experiment. Let's take the sample sway here. Suppose that I have a very simple apparat. I put detector here, and I will send electrons. The electron is coming here and here. Like you have two doors, we have ensemble of people to go from here. Like exactly, I can go from here or from here, right? There is two possible doors when you leave. Okay, then I am observing with the detector where the electron coming, okay? That's very important. I am observing, and then the particle, the electron behave like a particle. Now, suppose no one observed me, and I have two possibilities of the door, and I am in the quantum universe, you know? So, as an electron, what is doing here, the pattern here, what you can see, is a pattern similar to this one here. What means that? That says the electron is a wave. Wait a moment. Is it a wave or particle? You frustrate me now. Okay, you are speaking about electron as particle, and you are speaking of electron of a wave. Or what is? Yeah, say think about a cone. You have two faces, and always depends of the situation. I can use one of the faces, but the cone is the same. Okay, and this is exactly the duality between wave and particle. This is the concept. This is the concept, and this is the proof of it. Okay, and once I observe, quantum particle, it behave like classical, like particle. When I didn't observe, I don't observe them, behave like a wave. This is beautiful. Right? That is the observer change the behavior of the particle. This is what is important in quantum mechanics. That's the observer change the behavior of the quantum system. This is very important. It's like here. Let's go to furthermore, and this is more nicer if I see the concept is not only for electron. That is for every quantum entity, even for me. I am wave and electron. Sorry, a particle. You don't believe me, right? Because I don't have the interference effect. And this is very simple because of this equation here. That's the lambda describe the wavelength or the wave. And here the mass describe the particle. There's a relation between them. But if you see this relation, in particular, there is this constant here. You don't believe. This is the constant of Planck. This is responsible of all quantum effect. Here, if the constant here is 1 over 1 with 0, with 34 0, it's too small. So that means, since I have a mass, okay, and with this constant here, very, very, very small, my wavelength is very short, very, very short. It's tiny. It's 10, I don't know, maybe minus 40, minus 50, I didn't calculate that. But in that sense, that means my effect, my interference effect cannot be. It's very short. So, but that's why I behave like a particle, classically. Suppose we are in another universe, parallel universe. And suppose this constant of a Planck is not with this value, with 1, for example. What's happening? I will behave, and I will see the people behaving quantum. That means people are able, when you don't see them, to go in the same time from the 2 doors. Okay? When you observe them, they go one of them. Okay? That is the behavior will be quantum. Believe or not, this is possible if we change the constant of Planck. But it's in our universe, the constant is already established. Okay? So, parallel universe exists or not? Dr. Shawqi can maybe tell us more than that, okay, about it. And then another thing, the effect of tunneling. So, do you believe me that when I told you I will jump, I will go there? You don't believe me, right? No. That means I should have energy to go there. That is the wall between us. So, let's see what's happening in quantum physics. This is really experimental done. It's the alpha particle. Alpha particle is mainly the nucleus of helium. That means 2 protons and 2 neutrons. On this, they have observed that, forget what is MeV and so on. This is more technical. They have observed that the energy with 4 and 9, I will not say what is this, mega electron volt, but forget the unit. It's not important here. 4 and 9. They are able to jump and to go through 30 electron volt. That means like I have 2 meter length and I am able to jump there, from here to there. And I go out. You see me out. It's impossible, right? For classically. I come here, and I'm jumping from there to go there. That's not possible. This is not possible to jump. But I will be, you observed me for other side. Oh, okay. This is not possible classically. This is the proof that the classical alpha particle never leave the nucleus, and that will be alpha nucleus. That means we cannot observe this one here, the possibility of have what we call it alpha decay. But we observe it. This is the tunnel effect. How to explain that? So the explanation is that a small, you have wave, you can see the wave here, and there's this probability to go through, and you have here describing the probability. That means part that you have probability. I will not talk technically. That you are going through the wall. That means here, okay, this is what we call it an effect. Okay, why I don't go through the wall? This is the question. Hold for a few seconds. I will answer you. So let's here is we have the classical picture of electron. If the electron doesn't have enough energy, he will be reflected. That is the barrier, what we know. But now, if we go to quantum, electron as a wave has a probability to tunnel. So let me explain that. If I have more energy, you can guess. I have more probability to tunnel. If I have big mass, if I have big mass, I reduce my chance to tunnel. But if I have big mass, I have more chance. Here, my mass is too big, so that the probability to see one person traveling the wall in all the universe is less than 1. That means less the probability is almost 0 to have someone passing through the wall in our universe. Because of this again, sorry. Because this constant of the Planck. Suppose now, we are in universe, and parallel universe with the constant of Planck 1. what you will see people that are going through the walls. That is no barrier for them. They have chance to go. And thus they are behaving like quantum systems. This is beautiful, yeah? And this is now the application, you see, very strange properties. Could you take an advantage of that? Could we take advantage of that? Yes. Let's speak about application of quantum theory. Quantum theory was developed mainly to understand, as presented before, to understand the structure of the atoms. And developed by, also one of the explanation was supported by the Schrödinger equation, which is published in 2 journals, Annals of their Physics, and the other one is the Physical Review in 1926. They're very prestigious journals at that time. Then quantum theory is now becoming fascinating fundamental theory in modern science. Beyond atomic physics, it's used to describe nuclear structures. If anyone speaking about nuclear, high particle physics, what is the tool? Dr. Yusuf? Quantum. And then you have nanostructures, then you have nanotechnology. What is the tool? Quantum. And then you have chemical processes. People speaking about chemical processes, atom, orbits, SPD, and so on. This is quantum. And then, we know. Let's give you something that you don't know. A little bit you don't know. That is, we can now have a field of quantum biology. We are trying to understand in the atomic structure what is going on to understand what is going in biology, in DNA. People speak about quantum mechanics of DNA. And I am proud that I worked with my collaborators. I didn't work in quantum biology, but my collaborators were able to publish this journal in Proceeding of National Academy of Science. This about the quantum heat engine. Okay, now this is books. When someone is interested to the books, this is the books here about quantum effect in biology, quantum biology and information theory, and then more intriguing, finance. Finance, how to do with finance, with quantum finance. People speak about quantum finance. And this guy has published a book about quantum finance. When you see wave function, remember, wave function, and what? Stock market. Oh my God. And then here's people speak about stock markets and quantization. Hamiltonian of European options. That means quantum mechanics of European. Yes, yeah, you see, that's still confusing me. This is not normal. No, this is normal. This is a science. What is the power? They use the power of quantum physics. What is the power of quantum physics? The tools, the mathematical tools. So let me explain here an example. If people are from finance or from banking domain, they have the equation, like a Newton equation, is the Black-Scholes equation. This Black-Scholes is developed by two scientists, Black and Scholes, and developed in 1973. And now, from that, all the bank, they are used for theory of options, to calculate the options. So, in 1997, they get the Nobel Prize. So, then, in order to derive this Black-Scholes equations, and to drive after the solution is a hell. They are mathematicians, by the way. So, I think this guy, he's theoretician in quantum theory. And then he was taking the quantum theory tools and was able to derive the Black-Scholes equation in few lines using the tools of quantum mechanics. That means quantum mechanics is not only concepts, but also the tool, the mathematical tool of it, giving us the power to solve problems in another way. So I think I was speaking too much about quantum finance. Let's go better here. Application in quantum information. 1 month ago, we get the largest quantum computer created by atom computing with 1,180 qubits. That is also surpassing Google, surpassing IBM. It's a small company, but it's possible with imagination. You will see here. And now let's speak about application. Mainly we will concentrate about quantum computing. We want to understand what is the quantum computing. Okay, in order to understand the quantum computing, let us cite some recent progress in technology on science. A few years ago, people thinking about going to the Mars. And that's just Emirates is thinking about it in within 100 years to populate the Mars planet. So there is technique. You should build houses, right? How to build houses? So they discovered that it's possible with a 3D on using the Martian dust to build these houses. We don't need to have bricks from the Earth. Just bringing the dust of the Mars and then giving us ink for the 3D, and we are printing in 3D the houses what we need. This is the recent progress. Second thing, here. Wait a moment. It's not going. So this one here, artificial intelligence and stability control. This is the artificial dog. It's more stable than the dog itself. Okay? Then here, in astronomy. In astronomy, that is the Nobel Prize above the detection of a gravitational wave. But that is gravitational wave becoming an instrument. We speak about gravitational wave astronomy. Let me explain. In astronomy, we have telescope. We see the stars with telescope and detect that. This is the light for us. And this is radio telescope. We heard the cosmos with the radio frequency, and that gives us the information about the cosmos. Another way is to use the detection of gravitational waves to understand what is going on in the cosmos. This is a new tool for us. This is why they obtained the Nobel Prize, not only because they prove the existence of the gravitational waves, but also, and then Einstein was right in his prediction of general relativity, but it's becoming a tool, very powerful tool. And then here. People speak about going to the Mars. Also, in the best situation, in defined windows of time, you can go to the Mars between 6 and 8 months with the best rockets that we have. So people think about to develop plasma rocket, and is in developing. Maybe within little bit more than 1 month, you can go to the Mars, and you are not stuck with the tricks to use the gravitation in order to accelerate. So here, and this is the nicest one, I think. Editing the gene, editing the DNA. What means that? This is the CRISPR, which is a Nobel Prize of Chemistry 2020. They are able to edit the DNA, to correct, to cut, to add. What is the application? I think directly you think about Jurassic Park, right? That is species rebirth, really. Yeah, it's possible with technique maybe to reconstruct, to rebirth the dinosaurs. The Jurassic Park, to construct Jurassic Park. Plants more resistant to disease, create cell models, cracking complicated diseases, cancer, like a cancer, fixing genetic fault that cause diseases. So, okay. Why I am speaking about this? Because this emerging technology on science was not possible without having a significant computational power. That is, the computation is needed to develop all this science on all this technology. And then this here is a supercomputer. You see the dimension of it. It's very big dimension. Okay? Power for us is important. Power of computation is important. But heavy computation, we did heavy computation. Why we need heavy computation? To simulate physical, chemical system on conception of new materials. Simulation of the universe on evolution. DNA, artificial intelligence, simulation complex system like finance, predicting rare natural phenomena, the volcano, earthquake, hurricane, exoplanet exploration, and then control of aerospace. But that's just a few examples that I cited, or more than that. All lead or based on heavy computation. And we don't have enough computation to do all this in the right way. So there is another problem also, big data problem. what is the system produce more than ever data in human history. So let's give an example, very simple. Here, the internet produced 100 zettabytes annually in this year. In this year, it will predict to produce internet 100 zettabytes. What is zettabyte? Is, you see here, 12 with how many zero? 12. No, not 12, 22. It's astronomical number. That's what we produce. Okay, more than that. LHC collider, in order to detect particles, they are producing annually 25 petabyte, 25 with 15 zero. So what they do, Dr. Muhammad Yusuf know, that is when they detect, and Dr. Shawqi also, when they detect the collision, there is spicy, there is maybe new particles, but they don't have enough power for data, on too much data in short time, they select randomly the data, right? I'm wrong, all right? Yeah, okay, that's at least I understand something from that. Okay, and then that's the total number of operating satellites that's turning around the Earth. How much now? They are 7,702 through the statistic done in May 2023. So typical satellite, military, spying, telecommunication, whatever, they are generating 2 petabytes. And then we have really a big data problem. And data processing in real or reasonable time. That means I give you a lot of work for a short time. So that is the problem. It's like someone asking you to do a lot of things in the short time. We need to have a powerful computer, okay? So our goal is to enhance the computing power while minimizing the physical size of the computer. So I cannot have infinite dimension. Always I can put computer together. But it's nonsense to have big computers, big dimension infinite, because it costs too much. We should think other way. So the computational capability is based on transistor, these small, tiny things here. And this from transistor constituting the classical computer. What it should do, just I should reduce the dimension of the transistor. That is what is done between long time ago. And that is what we call it the Moore's law. That is every almost 2 years, precisely, even 18 months, the transistor dimension reduces to the half. That means I will have in microchip, I have more double of transistor every almost 18 months. They say 2 years, but almost 12, 18 months. And then I have what I have when I have more transistor in one microchip, what does it be? Doubling the power of computation. That means within 5 years from now, if I go classically, then you have 32 times power than now. It's 2 power 5. So just mathematical things. And then here, so let's return a little bit historically. The transistor of 1947 was a dimension of 1 centimeter, okay? But if I take this beautiful phone, Samsung Ultra S23, this one here, has 16 billion transistor. What is the dimension of the transistor? 4 nanometer. And then there is better than this. The i15, the iPhone i15, is a 3 nanometer, the transistor. They have more transistor then. So here, can we, by reducing the transistor size, we enhance the computation power. But we cannot go to infinite. What's happening? When you go to the nanometer, you begin to enter to the domain of atomic size. In that sense, the quantum effect emerges. What you do as classical, forget it. You should take attention. There's a quantum effect there. More than that, there is a lot of things. Heat issue. And then, what is? Researchers are looking at alternative solution. So I have problem with quantum. Why I don't take it as advantage for me? That is the idea. And that is the idea of quantum computing. So we enter now to understand a little bit what the quantum computing is promising technology. The birth of quantum computing, the origin of the quantum computing idea, is the Feynman, the biggest guy. Any scientist, any physicist know that. That's one of the biggest scientists in the physics. Here, introduced the concept of quantum computing. What is the idea? I have quantum system, and I simulate it by classical system. So why I don't simulate? That is not efficient, I think. You should simulate a quantum system, but quantum calculator. This is the concept emerged from that. So that's initiate the people to think. Okay, now in order to understand the difference between classical and quantum, let me begin to learn a little bit about the classical one. Computer based on bits on bytes. Always you are see megabytes and so on. So what is the bit on byte? The bit is the smallest unit of digital information. It could be 0 and 1. Lamp 0, 0 lamp off, lamp on. That's very simple. What is the byte? The byte is composed by 8 bits. So that gives me the opportunity to have 256 different characters. For example, A here, letter A, is binary and written in this way. You have lamp off, on, off, 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 on. So just by changing the lamp is off and on, we have possibility of 256 characters. Remember, when you read a book, English book, you have 26 characters, and there's written all the words in English. All the books is written with 26. Now, in the computer, we have 256 characters, including plus, minus, multiplication, special character, and so on. We have in the computer all memorized just by 0 and 1. That's how the classical computer works. The bit is the basic, just off and on. Beautiful. That is the geniusity of human. But now it's coming more. The quantum qubit. Okay, we have 0 and 1. Let's suppose it's very simple, to have 0 here, 1 here, and I can combine, just this state is a combination of 0, 1, in between 0 and 1. So, that's a qubit. I can have any possibility. I can run from 0 to 1, that's a 0, that's 1, on any combination between them. That's a qubit. So, you will tell me, okay, nice, very simple concept. Good, nice. But how we can realize that? Okay, we realize that exists. Atomic spins, in atomic physics, atomic spin can be qubit. Polarization of photon can be a qubit. Josephson junction, and too much others. Okay, I don't have the time to say it all. Now, let's take the following. Suppose I am in the universe with H is 1, where the quantum effect dominating. I am quantum Hisham. Not Hisham, quantum Hisham. And then here, you have here the state 1 holding the stone, excited state if you want. And then here, Hisham in rest. And in quantum domain, I can be existing and having state 0 and 1 together. No problem. This is in quantum field. In the quantum domain, in the quantum where the H is very big, remember. Okay, that's just hypothetically. Parallel universe. A copy of me in the parallel universe, in the way that's people in science fiction way of to speak. And now, you don't observe me, I am here. But once you observe me, I will be one of these states here. I will be projected in one of these states. When I measure, automatic. That's like electron. When you observe, it will be like particle. It will be classical. And that's the same. Here, when you observe me, it will be 0 and 1. That's beautiful. Here, that's just what is. I can do a lot of things with qubits, but once I measure, I project it to the classical. Okay? Now, suppose now 2 qubits. Quantum Hisham and quantum Zidane, my collaborator, preferred collaborator. And then here, Hisham in holding the stone, Hisham on rest, Zidane holding the stone, or Zidane. Now, I can combine them. But let me combine them in clever way. We call it this. Once Hisham is holding the stone, Zidane is on the rest. When Zidane holding the stone, Hisham on the rest. This is the combination of this state here. There is quantum correlation between us. That means suppose that Zidane is here, I am here, and Zidane in the other part of the universe. He's in Egypt already, but in other part of Bahrain here. And then, as holding the stone, Zidane will be on the rest. But once I go to the rest, Zidane automatic will be holding the stone. This is like a correlation between us. Without time. Just correlated. Just once I go to the rest, he goes to the excited state. And this is the quantum correlation, what we call it also entanglement state. This entanglement state is formed by the combination of these states here. Okay? And this is the basis of the, sorry? Quantum effect. collapsing in the universe. It's very nice. This is stopping in the best moment that I want to speak in quantum mechanics. Okay, I have done something. Charge of the laptop. No. The computer is working well. His computer is working well. That is what it's coming from. It's okay. That's very simple. That is the quantum effect here. That's good. That's good sometimes to know. And that's some break. Okay. Here, this is the power of entanglement. It's a crucial property to distinct quantum information from classical. Okay. Now coming genius guys. Catch that. Understand that. What they do? Sure algorithm. Power. They sure understood this concept. Taking this entanglement and use it in his favor and show that the quantum computer could efficiently factor large number. This is the first proof that the quantum computer can be much powerful than the classical one. And here, let me explain this factorization. Take the number, for example, 15. Can be decomposed in 5 multiplied by 3. The composition on prime number. That's simple. We learned maybe in school, high school. And then let's just remember that. In theory, if I get a large number with sure algorithm that will take like 100 seconds or less, classical computer will take thousands of years. I will not give you the number exactly how it's the number, a number of digits, because it's a lot of calculation or expectation, but this is the most realistic one, so to say. So here, prediction. Here, if we have ideal, that means if we have power computer. When I speak about quantum computer, I have millions of qubits. Not I'm speaking. That's in ideal case that they don't have any problem with qubits. We are not in there. Okay, quantum computer will break classical crypto system. That is the problem. We say, okay, good, you factorize prime numbers. That's this number. That's just only mathematical problem. No, it has big impact. It can crack the crypto system, all the crypto system in the world. Mainly, your credit card. You see, your credit card. This credit card is protected by RSA code. Cracked means your money is out. Bank is out. Security is out. Cryptography is protecting the sensible information. Cracking the information, cracking the RSA, which is based on the composition of prime numbers, means over. The security is over. That means, oh my God, quantum computer coming. Forget it. We do not have any banks, any security. No. When you have problem, solution exists. And the solution is the quantum cryptography, based on quantum concept to protect. And when we go to the quantum cryptography, the first quantum transaction was done in 2004. People were thinking very quick about the problem before even the quantum computer was developed in the right way. Until they have to make transition of 3,000 euro. So, and then election in Geneva was protected with quantum cryptography. And then here, China has shown that it's possible to transmit data using quantum cryptography with 1,200 kilometers. China is one not of developed in this field now. Okay, and that is what was irritating the Americans because the security. Now we will see why and what the American has done. So, quantum computation. allow us to have power in order to simulate, in the future, near future, simulate a physical, chemical system or concept of new material. Cryptography, enhancement of the cryptography, super security, because no, when it's quantum computer is over. But there is quantum computation give the possibility of quantum cryptography. Drug design and development, artificial intelligence, finance modeling, logistic optimization, exoplanet, a prediction of rare natural phenomena, volcano, earthquake, and hurricane. And then, this is the most important, maybe, slide that I have taken some moment, and when I discovered this. See, I will explain. By now, we are here. By now, here. The computational ability, our computational ability is less than one human brain. Whatever you have a computer, the ability that we have is less than one human brain ability of computation. When it's quantum computing there, before 2060, the computation will be more than the all human brains together. Realize that. By 2060, because of quantum computing, all the human together cannot beat the quantum computer in any sort of ability, mental ability. Because all our mental ability based on computation, even the creativity. So ChatGPT is a small example. It's nothing. ChatGPT is baby. Okay? Now the Americans, before the Americans, the quantum technology is gaining attention globally for its vital role in sustainable development or national security. That's all the world war about it. So Americans in particular now, they have developed quantum information is for them is a part of national plan on national security. For them, 2018 National Quantum Initiative is done, is an act. White House signed it. On their national security policy paper. And this is signed by the two last US presidents. Wait a moment. I'm almost there. The European Union has also established a new strategic roadmap for quantum technology to 2020. And they said we should master the quantum technology. China said also, this is in our plan, quantum technology, quantum computation is one of the priority. We should put a lot of money in it, okay? When you see this, all this, it's not only for security, it's business behind. So by 2030 is expected $4.5 trillion for business in quantum technology, quantum information. So here, what is this value? This is very big. If you see the GDP, the worth of every nation, so you compare it, you see that Japan, the third biggest or largest economy in the world, it has generated 4.2 trillion of wealth. That means quantum computing market will be more generating than Japan, the third biggest economy in the world. And then here, more than that, this is becoming now almost imagination. In 2017, they were able to teleportate what? The state of photon, the information, not the material, just the state of the photon, which is far 1,400 kilometers. They sent this. They have done quantum teleportation from this point with a photon. And this may be the future transport. See here, if I am able.
Ready to beam up, Jim. Energizing.
This is maybe our future transport of 50 years, when we may master the quantum teleportation of matter. And then here, this one here is what is the important, I think, what is my thought about it, that the future of quantum computing we reserve for us, is beyond, what will be reserved for us, will be beyond our imagination. Beyond of our imagination. That's imagine what you want to imagine. Maybe in the future something is beyond your imagination. And then, thank you very much.
جزيل الشكر للدكتور هشام على المحاضرة القيمة السهلة الصعبة في نفس الوقت، ولكن المحاضرة كانت لذيذة جدا. لأول مرة أنا أستمتع بالكوانتم ميكانيكس بهذا الشكل. شكرا جزيلا مرة ثانية، وخصوصا لجيل الشباب الجالسين، هذا مستقبلكم. لاحظوا إذا الكوانتم ليس شيء بس علم، تجارة، مادة، مستقبل. الآن نفتح المجال. If you have any question, comments, anything you want to ask دكتور هشام. First أستاذنا الكبير دكتور شوقي، أستاذ الجميع طبعا.
نعم. ميكروفون.
أوكي جست لا عندهم. أوكي.
أولا شكرا دكتور هشام على المحاضرة القيمة، بالفعل احنا استمتعنا في كل لحظة. أنا بس عندي تعليق شوي على الموضوع. في الواقع الكوانتم ميكانيكس عندما بدأ هناك شيئين مهمين في الكوانتم ميكانيكس. الشيء الأول هو التطبيقات، والدكتور ما قصر، يعني عرض طيف كبير من تطبيقات. كل واحد من هذه التطبيقات يمكن يحتاج لحالة محاضرة، يعني موضوع كبير جدا. الشيء الآخر اللي طرحه ميكانيكا الكم، واللي طبعا الدكتور هشام أيضا تعرض له، اللي هو البعد الفلسفي. الميكانيكا الكم في الواقع عندما بدأت كان هناك خلاف كبير بين العلماء على تفسير مغزى ميكانيكا الكم، وهذا الاختلاف استمر يمكن حتى هذا اليوم. هذا الاختلاف يعني خصص له كتب ومقالات وأبحاث كثيرة، وكان على قمة هذا الاختلاف هو أينشتاين نفسه. أينشتاين لم يكن يعتقد أن تفسير ميكانيكا الكم هو نظرية كاملة، وبالتالي هو اقترح شيء هو في ذلك الوقت يعتقد أنه يثبت أن ميكانيكا الكم ليست نظرية كاملة، وهذا احنا ما نسميه اللي هو روزن بودالسكي أينشتاين روزن بودالسكي بارادوكس، بي ار بارادوكس. البي ار بارادوكس هذا في سنة 35 لم تحل المسألة إلا في عام 1982 في جامعة وماري كوري في فرنسا، وحتى اللي هي موضوع الانتانجلمنت، التشابك الكمي. وحتى بعد أن حلت قضية التشابك الكمي هناك خلاف كبير على طبيعة التشابك الكمي. ما هو التشابك الكمي؟ كيف يحدث التشابك الكمي؟ في أي بعد من الأبعاد يحدث التشابك الكمي؟ يعني هذه كلها مسائل لها طبعا وقع فلسفي كبير، وهي لا زالت محل نقاش كبير بين العلماء. يعني هاي اللي حبيت أوضحها. الشيء الآخر، النقطة اللي أنا أحب أركز عليها، هي العقل البشري. أنا لا أعتقد لا الكوانتم كومبيوتنج حتى بعد مليون سنة سوف يستطيع أن يهزم العقل البشري. اللحظة التي يهزم فيها الكوانتم كومبيوتنج العقل البشري انتهى العالم. اللحظة التي يستطيع الكوانتم كومبيوتنج أن يهزم فيها العقل البشري معناها نهاية العالم. هذا يعني أنا اعتقادي فلذلك أنا أقول أن ميكانيكا الكم هي في الواقع ليست فقط يعني احنا ننظر لها كحسابات. العقل البشري ليس حسابات فقط، إنما شيء أكبر من حسابات. يعني يخرج أشياء ما ممكن تحسبها، أفكار جديدة لا يمكن بأي ميزان أنت ممكن تتوقعها. ما عدا ذلك أنا أعتقد أن إحنا راح يظل ميكانيكا الكم موضع نقاش، موضع جدل، وفي نفس الوقت هناك الجانب الآخر من ميكانيكا الكم اللي هو التطبيقات اللي ذكرها الدكتور، واللي هذه راح تكون لها يعني فتوحات جديدة يوم بعد يوم. شكرا.
شكرا. جست أنا فهمت السؤال اللي ركز عليه الدكتور واللي يحب يثبت ويحب يوضحه، اللي العقل البشري لا نستطيع أن نتغلب عليه بالكوانتم كمبيوتر. الآن في أبحاث قاعدة تنشر وقاعدة تشتغلوا عليها، اللي ما بين المايند تاعنا is quantum computer، لأنه احنا نخطئوا كثير. ميموري متاعنا لما نحاولوا باش نعملوا memorization of number sometimes أنا تقول لي الفون نمبر متاعك وأنا ردك عليه فما خطأ في نمبر، فهمت؟ ذاتس الخطأ هذايا معروف كذلك في الكوانتم كومبيوتينج. The superposition, interference, psychologists speak about interference. كل هذه الافكت اسمها لأنه احنا عقلنا في شيئين، فما المادي والغير المادي. فبالناحية المادية احنا عقلنا مكونة من ايونز، وحتى ترانزميشن نتاع الداتا والبروسيسنج نتاع الداتا تتحول بالعقل بالايونز، الكتريسيتي بالايونز. فكل الاوردر حتى انا باش نعطي امر هنا بيدي باش تتحرك، يجي امر اللي هو الكتريسيتي. يعني احنا نتحدث في الحدود المعرفه العلميه، ما نتحدثوش في الروحانيات. طبعا وقت تدخل في الروحانيات شيء اخر، بس انا في الحدود اللي هو راشيونال. وات از راشيونال، وات كان بي راشيونال. الكمبيوتر يولي باش يغلب الانسان. قبل كنا نحسب حساباتنا بيدينا، الكمبيوتر يغلبنا في الوقت. قبل كنا ممكن ننشو قصص، الآن ممكن القصة هي عبارة عن بعض الأمثلة، تبدل بعض النماذج فتخلق باترن اللي هي تخلق القصة طريقة هارموني. فممكن الكمبيوتر مش ذكي بالطريقة، بس جينيريتنج قصص 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 قصص، فأنت ممكن you catch one is the best. فهمت؟ وإذا تعطيه بعض الخاصيات ممكن. ففي أشياء اللي نحكيو عليها الآن، والخاصية اللي نحكيو عليها الآن في التغلب على العقل البشري من خلال الكمبيوتيشن. في الشطرنج تعرف اللي الكمبيوتر يغلب الإنسان. فهنا كل ما هو راشونال، لا نتحدث على الأخلاق، لا نتحدث على الطريقة، العواطف، كل شيء الكمبيوتر لا نتحدث على الكمبيوتيشن. حتى الكرياتيفيتي في حد ذاتها هي نوعا ما مربوطة ببعض كيفاش يقولوا الباترنز، فوق التجربة وغير ذلك. فأنا هنا الذكاء من ناحية هل الكمبيوتر يستطيع أن يختار ولا شات جي بي تي؟ خذ شات جي بي تي سهل. أي يا تفضل. أي شوف يا دكتور، ما نعرفش
في قضايا لا يمكن الكوانتم يعني نظرية المجال الموحد أو الأم ثيوري، هل يستطيع أن لو لم تكن موجودة هل يستطيع الكوانتم كومبيوتينج أن يكتشف الأم ثيوري؟
لا خلينا نتكلم لحظة نفسر لك. في الآن في الارتفيشال انتليجنس أبحاث بروف تيوريمز. يعني الآن عندك تيوريم وانت تحاول باش تعمل بروف. mathematician is the mathematician trying to do that. The computers trying to do to search for all the possibilities. انت الانسان الكرياتيفيتي نتاع الانسان، وعندك equation تمشي لايكويشن اخرى. somehow you guess. بالنسبه للكمبيوتر يحاول كل possibilities والاحسن يمشي فيها. فما بروف تيوريم اللي هما فيه الان الريسيرش هذه. بالصدفه انا شفت ناس يعملوا trying to verify البروف نتاع الماثيماتيشن. فما بروفز تتطلب وقت كثير والاخطاء صعب باش تلقاها في اللوجيك، يحطوها على الكمبيوتر. الان شوف ماثيماتيكا، خذ الماثيماتيكا سهل جدا. integrate, differentiate, do tensor product, do etc. This process is what we call it machinery process. في creativity is نوعا ما كل بماشينري، مش دائما. انا من خلال اللي نتصوره اللي احنا في حد ذاتنا المايند نتاعنا قاعد يجرب ويتعلم. This is what we call it machine learning. Maybe quantum machine learning could be mimicking us. يعني كان تجم تبع طريقة التفكير نتاعنا إذا وصلنا. فهنا أنا كساينتست نتحدث في المجال العلمي ولا نتحدث في مجال الروحانيات أو الأخلاقيات أو شيء. كل ما يستطيع أن يقوم به في الميادين الراشونال، كل ما هو تفكير نمطي. التفكير النمطي متاع الإنسان أنا أتصور لفترة معينة حنصل لها. كل ما هو تفكير غير نمطي مرتبط بالعواطف أو بطريقة معينة ممكن ما نوصلهاش. بالنسبة للسوبر سيمتري والام تيوري، أنا نجم نقول لك اللي لو عندنا كمبيوتر سوبر كمبيوتر، نمشيو 30-40 سنة في الكوانتم كومبيوتينج ونجرب كل الأشياء البوسيبل، هل فما ريليشن بين هذه وهذه، نشوف البارامترز، نشوف الأشياء. فممكن كوانتم كمبيوتر one time discover something link. طبعا الإنسان حيتدخل يقول this is a hint. الآن الكوانتم كمبيوتر مثلا نعطيك اكزامبل سهل. أنا نحب مثلا نقع في معادلة أو في بعض الفينومينا ونحب نربطها بفينومينا أخرى، ايش نعمله؟ الكوريليشن. نصور النقاط ونشوف هل لينير كوريليشن ولا نون لينير كوريليشن. الكمبيوتر يساعدني في هذا. إذا لينير سهلة، بس نون لينير كوريليشن الكمبيوتر يساعدني في هذا. من خلال هذا أنا نستنبط القانون. ممكن الكمبيوتر will be an extension of our ability of the mind. هل يتخطى بالطريقة اللي قلناها هذه؟ يتخطى في الأشياء النمطية، حيتخطى. أحببنا أم كرهنا حيتخطانا. الآن تقول الكاتب متاع القصة يقول لك أنا أخاف على مكاني لأنه الآن تسأل شات جي بي تي يكتب لك ما تريد. فهذا ما كناش نتصوره. حيتخطى في بعض المجالات، أو كل المجالات الله أعلم، بس حيتخطى. هو بدأ يتخطى في المجالات معينة. هذا ايش حبيت نقوله يعني. الطريقة ممكن اللي بس عملت بريزنتيشن is confusing، بس هذا ايش نقصد به بالضبط.
هي يعني شوية في لبس. احنا قاعد نقارن عدد ترانزستورز قاعد يزيد. ليش؟ لأنه البروسيسنج سبيد كل ما زادت البروسيسنج سبيد you need more transistors. فبالتالي كل ما توصلت لطريقة يعني تسمح لك بزيادة السرعة، فهذا هو السكيل اللي رايح من كلاسيكال كمبيوتر لكوانتم كمبيوتر. فيمكن الريفليكشن على الهيومن مايند شوية ملوش يعني ما فيش يعني. أنا أتكلم عن بروسيسنج سبيد وكيف قاعد تزيد الكمبيوتيشن باور، لكن الهيومن برين يعني بروسيسنج سبيد ما لهاش ربط بذاك.
نعطيك اكزامبل.
هذا اللي قاعد اشوفه.
ناخذ درايفنج كار، سيلف درايفنج كار. اوكي، انا اسوق، تجيني الايمج نرى فيه مشكله هناك ولازم نتوقف. كم ناخذ من وقت؟ هذا في العلم. كم ناخذ من وقت تو بروسيس ذا انفورميشن. جاتني الانفورميشن هنا و اي ويل بريك، مشيت على الفرامل. كم تاخذ وقت؟ 0.8 سكند تقريبا، يعني رمشة عين 0.8. الكمبيوتر كم ياخذ؟ depends of the computational power. يعني بالتالي الكمبيوتر يجم السيارة تتوقف وتحميك من الاكسيدنت قبلك انت. فالابيليتي هنا تساعدك باش تحمي روحك. هذا ايش نقصد به؟ يعني سم ابيليتي عند الانسان، انت لما تحسب كالكوليشن كبيره تاخذها بالقلم والورقه، هل تستطيع تعملها؟ تاخذ لك وقت وممكن تخطئ. الكمبيوتر لا، اسرع. في ابيليتي اللي هي يسميوها النمطيه الراشيونال، اللي هي باش تتطور عند على الكمبيوتر بصفه عامه. فهذا ايش نقصد؟ هذا هو الاشياء اللي احنا نعملوها بصفه نمطيه ويتطلب السرعه. الكمبيوتر يعملها اسرع. حتى الموسيقى نفسها اللي فيها كرياتيفيتي، انت عندك نوتس تربطهم بعضهم بطريقه معينه وتعمل هارموني. حاول باش تلقى بعض النمطيه في الهارموني وقول للكمبيوتر يخلق لك سيستم فيه من فضلك ما تحطش دو بفتر ري مع بعضهم، ولا حط ما تبدلش دو ما تعملش 3 مرات. تعطيه بعض النمط او النمطيه اللي لازمها تكون بعد الدو اوبليغاتوري ري. فانت تخلق موسيقى اللي هي الفنان ما غير ما يستوعب هذه النمطيه. واحنا في النحو، في الصرف، لما كنا نتكلموا باللغه العربيه او في التصريف، الان بعد عملت قوانين النحو والصرف، وبالقوانين هذه نجم نصلح. وبهذه القوانين نفسها الكمبيوتر يصلح لك الاخطاء النحويه. مش الكمبيوتر يفهم العربية ما يفهمش، ويفهم الإنجليزية ما يفهمش، بس هو بالقواعد اللي عملناها يفهم. فالقوة في الإنسان اللي يحطه يستغل الكمبيوتر. فطبعا هنا إذا كان الكمبيوتر programmed in the right way يمكن يغلب الإنسان. بس طبعا هنا الطريقة كيف في شيء آخر زاد الآن هي what we call it quantum machine learning. الماشين ليرنينج يعني يتعلم. في أي مجال نجم نوصل الماشين ليرنينج يعني هو يخلق أنماط معينة، يستفاد من أنماط معينة، من باترن معينة ويستعملها. فأنت ما تعطيه نص بالعربية من غير قواعد ويقعد يتعلم يخلق القواعد النحو، او يكتشف مش يكتشف القواعد النحو ومن بعد يولي يصلح لك من غير ما تعطيه القواعد. هذا هو ما يعبر عنه بالماشين ليرنينج وديب ماشين ليرنينج، ويتطلب كومبيتيشن كبيره. وهيك علاش نحاول باش ندخلوا بالكوانتم كمبيوتر ان اوردر تو انكريز ذا البوسيبيليتي. فيعني الطاقات العقليه نتاع الانسان فيها ديفرنت كما يقولوا تصاعدية. فيها الأشياء السامبل كالكوليشن، أشياء اللي فيها ديسيجن، أشياء فيها هذه، وهذه كلها مبنية على التراكم اكسبيرينس وكالكوليشن. فممكن الكمبيوتر نوعا ما حياخذ إذا ما قلناش كل بارت كبيرة من الكاباسيتي نتاع اليومين.
I was just going to add to that. sorry عربيتي تعيسة شوي بالتكنيكال. بس للدسكشن عن الماشين ليرنينج والاندستري 4.0 وال the digital transformation and the masses of data. انت حكيت على 120 zettabytes this year. The human brains combined would take us forever to try and decipher this or take information from it. The idea of machine learning and quantum computers, as we generate more and more data, how do we derive that? For instance, when we have more sensors for weather, so that we can accurately predict weather, which is always very, very difficult. We can predict within a few. For the advent of quantum computing would drive the developments that will occur, and you know, we talked about creativity. There are some applications now on the website that says, you ask it, please can you draw for me something? And it creates a beautiful painting.
I use it, some images.
And it writes stories. It may not have, but what it's based on, it's human knowledge. So our combined knowledge and the data that we've created creates that foundation for the machine learning and the quantum mechanics that will help us to get to where it is. It's the massive data that we're producing that's driving these things to solve problems. Like global warming. I mean, things like that are very, very critical. Whether, like you say, it's a philosophical question, will they ever replace us? The father of machine learning and AI believes, he resigned from his position and he's against it, the Canadian gentleman, and he believes that it's a danger to us. Allah alam, no one knows.
شكرا جزيلا. احنا
Well, if no further answer, just in a hurry. Yeah. You mentioned something about quantum biology. Yeah. Okay, so it seems a flourishing, field. Yeah. So here, life, is it quantum mechanical phenomena? Life itself, how can we explain it? الوعي مالنا.
لا هنا ما ندخلش في الميتافيزيك.
لا مو ميتافيزيكس.
يعني نتحدث عن الانسان كخاصيات الانسان.
Exactly.
الانسان هو متكون من اتومز molecules.
Yes.
On the way.
Yep.
So والاتومز شنو اللوس اللي تتحكم فيهم؟ هو الكوانتم. فبالتالي احنا ريزلت بتاع الكوانتم.
So there is some wave functions in our brain.
Yeah.
Okay. So here's the idea. So how come this? How can we put it as a quantum mechanical phenomenon? How can we explain it with quantum mechanics?
Okay. بس تدخل هنا في نقطة اللي أنا ما نجمش نجاوب عليها بصراحة، تعداني. بس اللي أقول لك عليه اللي وقت ماشين ليرنينج كان learn something، هل عندها conscious ولا؟ سؤال. هذا الماشين ليرنينج لما صارت experiment في جوجل وقفوها. وقت two machines created a language to communicate with each other و stop it. هل صارت الكونسيوس ذات ولا؟ هل هو الآن أصبحوا تطورت؟ هل وصلوا باش يعملوا لغة to communicate with each other و stop it وقالوا وقفوها خافوا لأنه الماشين ولو عندهم قدرة باش يتعاملوا مع بعضهم. هل صارت فيها كونسيوس ولا ما فيش كونسيوس؟ ما نعرفش. we don't know. واللي يخوف هذا النطاق، هل هو صارت اتخلقت
شوف أنت لما طفل صغير يتولد بعد فترة معينة يرى أطرافه، هذه في البيولوجي معروفة. فأطرافه في الأول ما يعرفهاش اللي هي ليلو. الوعي بالذات هي شيء من أشياء خاصياتنا الإنسانية، فما يعرفش يديه هذا ليلو. لما يتحرك فترة معينة يتعلم هذا بدني، هذا خاصيتي وهذا خاصية الآخرين، واللي يفرق بين أمه وأبوه وعمه وجده إتسيترا. فالوعي بما هو موجود عنده هو تعلم، نوع من التعلم. هل احنا الكمبيوتر يوصل باش يتعلم الاشياء الاتيه؟ يتعلم الوعي بذاته، وعيه بالكوميونيكيشن مع الاخرين، وعيه باش يفرق بين الكمبيوتر وبين الاله وبين الانسان، وباش يعمل عداء للانسان او باش يكون صديق للانسان. هذه اشياء نقطة صعبة باش نجاوبوا عليها، لأن ما نعرفوش. ما نجموا نجاوبوا على نقطة كان ما نجموا نعملوا اكسبيريمنت بيفور. نعملوا الاكسبيريمنت بيفور ما بين بعد الكمبيوتر ياخذ الباور.
This is what worrying Professor Shawri, that no way to reach
أنا ما نجمش نقول في الساينس no way or not no way, but I will say I am very prudent about it. الباور نتاع الكمبيوتيشن is too high now. With quantum computer it will be bringing more and more power. We don't know what is في الأخير. Maybe there's something that we cannot imagine what is going on. It's beyond our imagination. Believe me, this is beyond of our imagination. أنت لما نرجع نعطيك example. خذ الإنسان 1900. هل كان يتصور فما هاتف يتكلم بالسكايب ولا بالزوم؟ يتكلم واحد بعد 1000 كيلومتر ولا 2000 كيلومتر بعيد عليه ولا 10000 كيلومتر بالهاتف؟ 1900 هل كان يتصور هذا؟
لأن التكنولوجيا
مش حتى الانسان ما يجيبش يتصور، ولكن احنا بعد 50 سنه هل نجم نتصور شو ما يعملوا؟ بعد حتى 10 سنوات. انا نفسي وقت كانت عام 2000 كان ندرسوا في المدرسه فما كتاب، والكتاب يتحدث عن المستقبل عام 2000، فيقول لك اخذت ام الهاتف تكلم ولدها وتراه صوره. صار الان ولا ما صارش؟
صار.
احنا كنا نضحك كيف واحد بالصوره يتكلم والهاتف معاه.
مستحيل.
كنا نضحك واحنا في عمرنا 10 و 15 سنه، هذول غبيين، هذول ناس ما يتصوروا. ولكن احنا الطاقه العقليه نتاعنا والايماجينيشن نتاعنا ليميتد. الان تتصور اللي الديفلوبمنت نتاعنا في سنتين، يعني كل سنتين we are doubling almost our knowledge. يعني acceleration is too much quick. يعني ما نجموش نتصور ايش باش يصير. فبالتالي نكونوا حذرين. انا لا استطيع ان اقول لا، ولكن اقول ممكن مع الاحتماليه. هذا كم ساينتست. وقت تدخل في حكايه الكونسيوس وحكايه العقل وحكايه هذايا الامور هذه تدخل كذلك ارتباط ديني، وبالتالي تولي الامور الجواب بتاعها صعب. الله اعلم. ربي سبحانه وتعالى اقول لك شيء انا تعلمته كذلك اللي احنا اخذنا في الفيزيكس سهل جدا. فوت احنا 2 dimension. تعرف 2 dimension هي يعرفها الدكتور شوقي جيد جدا. In 2 dimension you can move only in the plane. تصور احنا ناس عايشين في 2 dimension ويجي واحد من 3 dimension يتحولهم من هنا، هما مربوطين في المنزل، يحول واحد من منزل خرجوا. استعملنا dimension اعلى، صح؟ فهذا احنا طريقتنا احنا مرتبطين بكل ما نعرفه، اعتبروا احنا ديمنشن بتاعنا. فلو ان في ديمنشن اعلى تجب ممكن في طريقه اعلى، فهي تجب تعمل الاشياء اللي احنا ما كناش نتصوروها. فنجم نقول بنفس الطريقه. Alien maybe if there exists, maybe they are in super dimension and they have more power, more things.
دكتور هشام إذا يا شكرا دكتور هشام. في الحقيقة يعني موضوع فلسفي جميل جدا ومهم وحساس يعني يعني بعض من اللي قلته شوية خطير. يعني نجو إلى قصة superiority تاع الآلة على الإنسان وحاجات هيك يعني. بس في نقطة ربما تغافلنا عليها، وهي أنه عقل الإنسان يتطور. ما ننساوش هذا الفاكتور. يعني أنت الآن تقول لي أنه إحنا منبهرين جدا بالتكنولوجيا الحديثة مثل ما كنت تعطي الأمثلة وكذا،
ولكن هذه تبهر شخص من السبعينات والثمانينات. الآن الشاب ما ينبهر أبدا، موبايل سريع أو يبعث الصورة معه. فبالتالي أنا أعتقد أنه إذا تطورت الكمبيوتينج بالسرعة اللي أنت تقولها، أنا لا أشك في ذلك، بالصح في ذاك اليوم يصير الإنسان يتعامل معها بعلو كعب، ما في مشكلة، لأنه الإنسان ما زال سوبريور. هذه آلة من آلاته. يعني الإنسان كان يمشي، بعدين الحصان، بعدين السيارة، بعدين الطائرة. فهو عبارة عن تطور هو امتداد لحواسه. حواسه أو جسمه يستطيع أن يقوم بشغل معين. الآن الآلة تسويه أسرع أو أحسن. الإنسان يقدر يرفع 50 كيلوغرام، صنع آلة ترفع آلاف المرات 50 كيلوغرام، عمرها ما كانت تسبب خطر عليه أو تكون سوبريور عليه. فأنا أعتقد أن هذا التطور اللي يحصل لن يهدد الإنسان في علو كعب الإنسان، وأنه هو الخالق بين قوسين إلى هذا التكنولوجيا، ويبقى هو محافظ على الريادة. ما فيش مشكلة على ما أعتقد. وثالثا أخيرا، يعني أنا وشوقي ما راح نكونوا موجودين في ذاك الوقت، خلي اللي يصير يعني.
يا دكتور، يا دكتور، لا يا دكتور إن شاء الله يطول في عمرك. بس الأمور هذه جاست نحب نجاوب على نقطة. الشباب الآن أنا نتذكر وقت كنا نعمله في الرياضيات without calculator، أوكي، حتى في وسط الجامعة. الشباب قادرين الآن باش تعملوا calculation بيديكم، تعمل to derive the square root of a number. You take a lot of time, but you don't have the habitude of it. يعني we lost some habitude. يعني بالنسبة لنا احنا ولينا نعتمدوا على الكمبيوتر، بحيث احنا الهابيتود متاعنا نسيناها. الآن وقت تكتب رسالة، هل تستطيع أن تكتب رسالة وتبعثها من غير ما يتعدى على الكمبيوتر لعل فيها أخطاء نحوية؟ قبل احنا كنا نكتب رسالة من ألف إلى الياء. شوف الخط متاعنا، جمال الخط قبل. أنا وقت نمشي نكتب على السبورة ونطلب من طالب من فضلك إجا يكتب شيء جاوبني، دق الخط مختلف، لأنه احنا بالوقت قاعدين نقصروا بعض الأشياء اللي تعلمناها أو بعض الفاكولتي اللي تعلمناها، وكأن بالنسبة لنا الكمبيوتر ونعتمد عليه. فأنا بالنسبة لي صحيح احنا قنوية adapt ourselves. نشوف الجينيريشن هذه جميلة جدا، الجينيريشن هذه، بس المشكلة متاعهم هما كم من ساعة تعديوا في الفيسبوك، سوشيال ميديا. تعتقد هل هم الآن عندهم الوقت باش يجوا يطوروا بعض الأشياء؟ احنا خسرنا الوقت، الآن الوقت متاعنا وتكلوا التكنولوجيا، فبالتالي التطور انتهى الوقت، انتهى وبالتالي فاحنا بالنسبة لنا أنا معك، ولكن احنا قاعدين نخسروا شيء ونربحوا شيء. فهمت؟ هل هو البالانس بين ربحنا وخسرنا يكون جيد ولا لا؟ الله أعلم. يعني أنا بالنسبة لي لو الآن انطفى البروجيكتور فور ثانية، قبل ايش كنا نعمله؟ سلايدز ونتبع على السبورة. الآن لو انطفى مانيش بنعمل حتى شيء، ننتظر عشان ترجع. يعني الاختلاف الآن، أنا بيدي نفسي الميموري متاعي الآن ما نجمش نتذكر كل شيء، ولا سلايس هو اللي تساعدوني، صح؟ فلما نطفى حنتذكر السلايس الكل، طلب لي وقت. قبل شد السالها ويكتب اكتب وانتهى الأمر. يعني أنا ماي ابيليتي وليت ننسى أشياء ونطورها في أشياء أخرى. فالمشكلة هنا هو الإنسان نفسه، الشخص، مش الناس ككل. إذا ترى الناس الكل احنا قاعدين نخسره، لأنه برشا نضيعوا برشا وقت. بس احنا كإنسان انديفيديوال هو اللي يطور نفسه، هل يستفيد من التقنية أو يضر نفسه بالتقنية هذه. يعني عندك سلاح، هل تستغل ولا لا؟ هذا الفلسفة اللي أنا أتصورها. يعني
في الختام، أولا احنا كنا نتمنى نستمر والله، بس الوقت. أوكي دكتور ناصر، آخر سؤال. أنا دكتور ناصر يكون آخر سؤال، وسؤال صغير يعني.
طب أنا أشكر الدكتور هشام، أشكر الدكتور هشام اللي اداني الشانس دي، اللي كانت الدكتور محمد أجيها لي بكرة، فهو جزاك الله خير إن اديتني الشانس دلوقتي إن شاء الله تعالى. anyway أنا بشكر حضرتك على المحاضرة القيمة ديت اللي ثبتت بعض المفاهيم الفيزيائية. نعم أنا بشتغل نفس الشغل، رياضيات نفس الشغل، ولكن هناك بعض المفاهيم الأساسية اللي ثبتت عندي بفضل هذه المحاضرة الرائعة. السؤالي أنا هطلع من الفلسفة وهتكلم سؤال مور تكنيكال شوية يعني. إحنا دلوقتي we are interested in how we can transfer classical information into quantum information. In fact, I can do some few particles as one particle, two particles, or one information, in classical information, I can transfer into quantum information. And I can do it my hand. I did spend more time. Really, mathematics can help me do something. Really, I would like to know if there is any mechanism that can transfer, because we have a huge number of classical information, and we need to treatment or develop or use this data as a quantum inside our quantum computer. So is there any mechanism or what we can transformation that can help us to transfer a classical information into quantum information at once to be used in the context of quantum information? Okay. Thank you very much.
أنت سألتني على سؤال نقطة اللي احنا البحث متاعنا يتسمى كيو ماب قاعدين نعمله. طريقة شنو؟ اللي الانفورميشن تعرف انت الكلاسيكال انفورميشن ولا كلاسيكال الجوريثم go to the classical algorithm based on the gates classical gates. So فيعني انت عملت algorithm وعملت classical gate. Can we transform it to the quantum gate؟ وغير ما نعملوا الانتنجلمنت كل شيء. The answer is yes. How؟ with a Q map. انتظروا البيبر متاعنا. الكيو ماب. الكيو ماب تحول الترانسفورميشن نتاع الجيتس to classical gates to the quantum gates without using now entanglement. To optimize also, because usually توفلي gate نستعملوا توفلي gate سينو. بس هذايا نستعملوه فيه نستعمل الآن احنا البيبر we are fighting for. صراحة بعثناها الجورنال واحد قال excellent والآخر قال we should justify we are fighting. لعل وعسى يتقبل إن شاء الله عن قريب. أعتقد حطيناها في الأركايف. You can see it. I will show you for that. Okay, thank you.
في الختام أولا شكرا جزيلا لجميع الحضور، شرفتونا اليوم في هذا المركز، وإن شاء الله إلى محاضرات مقبلة علمية بنفس المستوى. الشكر موصول إلى الدكتور هشام ضيفنا العزيز، قدم محاضرة قيمة، فألف شكر دكتور هشام، وإن شاء الله إقامة طيبة في البحرين، إقامة طيبة في البحرين، وإن شاء الله نلتقي في محاضرات أخرى. شكرا جزيلا للجميع.
نعم. المحاضرة إن شاء الله منتصف النهار الساعة 1 هتكون سبيشالايزد. الناس اللي very specialized will speak about quantum computer, the blueprint.
Okay.
يعني المسودة quantum computer using quantum.
إن شاء الله. الدكتور هشام عنوانه عندنا، تلفونه عندنا، الإيميل، أي شيء عندكم استفسار شيء إحنا نكون في تواصل معه. أهلا وسهلا بالجميع. شكرا جزيلا للجميع الحضور الكريم. بارك الله بكم والله.